Okay, so here is the tool head that I have designed for the Daedalus. So I decided to take it upon myself and see if there were any items on GitHub from the Project R3D group, and thankfully there was some frame items. There was the entire gantry, and I took some measurements from my Daedalus, and I came across, and then I pretty much came up with this assembly that greatly helped my whole build. And all of this is going to be linked in the description below if you want to take a look at their GitHub. I don't know if they have a full model of the frame or if you'll have to make it. I did make this a while back, but anyways, back to what we wanted to talk about. This is the new tool head that I have created. So the original tool head, I'll actually just put a little cut right in here to talk about the original tool head if you've missed that.
This is what was the old Toolhead. As you can see, looks pretty good. In fact, looks pretty new because I had to replace it. This is the old Toolhead, and this Toolhead ended up jamming like hell. It jammed so hard that everything from pretty much the heater up was unusable and had to be thrown away. I thought I could replace just this and this from spare parts I had, and I kept thinking about it, and I just thought I wasn't going to be happy with that. I want something new.
Okay, so this is the whole tool head assembly that I have created that is custom to this specific build. So the reason why I needed to create a custom tool head is that one, the original mounting design for the Stealthburner wasn't compatible with this this machine. So the original, design, as you guys know, is that the linear rails attach standing upwards, so it would move left and right with this facing. This would be the linear rail facing towards you, but now we have the linear rail, facing upwards, and so it requires a new design. So I took it upon myself to kind of go through and redesign this. I took some inspiration from the original design, and then I also reused a design from Vitalik 3D. I just wanted to show you guys what my specific design was, and if we can actually just take a look right here, you can see how it is very heavily inspired by his design, as it was placed right here. This is the original design. So I started off with this, and then I took it step by step and added all of the necessary holes and attachment features. I shaved off a ton of space that I didn't think we needed, and I added these winglets here, which is how the belts would be attached to the tool head and allow it to move around. So there is that. So I essentially took a couple of those items, and then I added a back plate here, because if I had just added this straight to this tool plate back here, it would have been a little bit wobbly. So as it's working, it's going to rock around like this, which would make it very, very unstable. So I wanted this thing to be super stiff and super stable, and I added a backplate here to reinforce it. I used some off-the-shelf hex standoffs that are going to be really good at strengthening up this entire tool head. And these parts are really, really light. I haven't checked the exact weight because the material, density and stuff for SolidWorks hasn't, for whatever reason, updated. But I'm assuming for this entire assembly here, it would be under 150 grams, probably around there. We'll have to check it in person. So future engineer here, and we put it together, and we finally weighed it, and it came out to 74 grams, crushing our goal. And the other thing that you'll notice is that we have the X probe right here in the back as well. In the original design, I'll see if I can get that up for you guys again, or just the video that you just saw. This X probe was in the back, and it was kind of in an awkward place. Mainly because it had to make room for that enormous old style leveling probe. Speaking about leveling probe, thankfully to this design is very handy for a lot of reasons, and it might look like that you would be losing a lot of space in the Y direction, back and forth on the printer, but you really don't, and you actually end up gaining some space in the Y direction, so that's amazing. And the best part about this design specifically is that it gives enough space to be able to put a new sensing probe back here. I think this is initially designed for beacon or other sorts of probes, but I made a little attachment guy right here, this little attachment that will perfectly place a pin to probe right in here, and then you're going to use a M2x10 threaded insert nut that's gonna pretty much just clamp onto it. And it's using these two little holes to actually mount to the underside of this plate right here. And yeah, it does a great job. I tested it by itself, and it looks like it's doing a great job clamping onto the pinda. And it looks like it's all gonna work out. On the, I think it's called the SB2209 board here, we're just gonna plug in this pinda to that, and we should have power and signal to go into that. So yeah, this is the custom board. So the next up part that I'm going to show you are some of the additions I needed to make to the actual deadlist to make sure that it worked. As you can tell, as the entire assembly comes in, I had to make this little bump stop here so that it could extend out the original bump stop that was just too short. And even in the original design, there was a little cutout, and it actually extended out the amount needed for this end stop to be depressed. But yeah, for our model, we had to extend this out a little bit, which ended up working, and we do get a nice click way before this, which is where the belts will run, will hit the idler gear right here. So yeah, there's that. And then the other thing you'll notice is that I'll need to make a Y end stop bump gear here, which is a little bit hard to model. I kind of have to just do it in real life and measure it and just kind of get a model that's close and then just print it and have that working. Or we could do some clever stuff and cut a hole in the back panel and maybe stick it into that. But yeah, that is pretty much the tool head here. And we will go ahead and show the entire build of the Stealthburner. I'm not going to show you a step-by-step guide on how to build the Stealthburner, but I will just show you a nice little montage of that. And then once we get that, we're going to build the our personal gantry onto this, and we will print out some parts as well. So we're going to print out all the Stealthburner parts. We're going to print out the pinda parts right here, and we are going to get these metal items assembled, and I will see you there. All right, so here are the parts I got from PCBWay, and I used them because they were really cheap and solid resource, and I've seen a lot of good videos about them. I'm not sponsored, but I really wanted to just show off how good the machining and stuff was. As you can see, this is the first part. This is like that front mounting plate, and it came out really well. All of the holes aligned, all of the counter bores were fitting. Thankfully, I don't have ultra tight tolerances on this part, but all of the threaded holes were there and they all worked. Especially this part that I was worried about. There were deep threaded holes in the sides, so it worked out perfectly. And here I am just like admiring all of this. And we've got lastly the back part here that honestly just looks beautiful, well machined, everything aligns in total, and I want to show you guys the weight. I wanted to do a little bit of a weight comparison. So we have the old tool head here, just missing some fans and some screws, but we should be able to get the majority of the weight. We're gonna get, well, there went a bolt, but that is roughly about 500 grams, 498 for the old tool head. So let's try out our new tool head. All right, so here is our new tool head with that new back piece. So let's put that on. Let's put the back piece on. And we are just missing this piece. 450. So we saved 50 grams switching over to this. And this system is going to be way more robust. It's going to be a lot better put together, and it's going to be a lot stiffer. So I'm very excited to see what the result will be on the input shaper graphs and all the actual parts that we make out. But so far, this is a little progress update on the tool head that we just that I just showed you. So here it is. It looks pretty cool, pretty neat. I have a little thing. We got the light hat. We got the lightweight, ultra high flow SB tool head, and we've got the actual parts here. And this part's, you know, like I was saying, these parts are really easy to put together. You essentially just take these three holes, mount them up to these three holes. So this is going to sit on the linear rail. It's going to sit like that, and then we're going to have three bolts mount into there, and then all of it kind of just sandwiches together like that. But you can imagine the middle piece is vertical, and it's going to be super stiff, super rigid, and it's going to be a really good good machine. So now what we're going to try to do is we are going to go through and try to mount it on here. And once I have it mounted, I'll come back and show you guys. Okay, I got the whole tool head on. You can see it from the side view here. All of its goodness. And it working every time, bro, every time. Anyways, yeah, here it is working perfectly. I did make a bit of an oopsies with this end stop placement. The model end stop I had used was a bigger end stop, so I couldn't have used both screws to screw it in. But if you tighten down one screw quite a bit, it's able to still work and not get deformed in place. So I'm kind of counting on that. But besides that, this is the whole tool head. It's looking nice, it's looking clean, it's a little lighter, it's feeling pretty good too. And I think I should be able to have enough room with a ball end screw just to tighten those screws on here with the belts when they're finally getting tensioned. But yeah, this is looking good. I hope you guys like the red Stealthburner. It really matches well with the red inlay and it's looking good. Everything is fitting well. The only thing I have to add left is the drag chain mount, which is going to look like that. And yeah, it's going to swing around and pivot, and it should be a perfectly good match for all of this. So, and if that doesn't really work, if it looks a little funky, or I don't know, it doesn't really work well in our case, then we can always go back to the other items. But I'm thinking it should work well. Maybe it might have to go upside down, but yeah, you know, we'll figure it out and we'll make it work. So I actually gravely underestimated the work needed for the just the drag chain part. I was thinking about it over and over again about what kind of cable solution I wanted to implement for our Stealthburner here. You know, our two options were to do the cable chain route, or to go with the PG7 cable that has like a metal music wire, similar to that's to what is used in the 2.4. I'm going to show a photo right here. This cable, you know, similar to what's used in such a photo like this in a 2.4, where it's just a single CAN cable with the two PG7s right here. So yeah, those were our two options. I really wanted to implement the original drag chain because there was already a really nice machined metal part that had all the correct hole patterns. So I was thinking, you know, I could use this one part that I had found on printables and I could just slap it on and make it work. And that was, yeah, of course, not going to work because the heights and dimensions were completely different than what were needed for the deadlifts. So I took some more time and I modeled out everything. You know, I added rails on the x-axis. I added the actual guide rail, and then I measured out the back panel, made the correct cutouts, and then modeled in a drag chain and the correct position of the drag chain holder and the actual motor mounts, and you know, found its position, found its heights, and then I had to make my own custom drag chain attachment, which is this little guy right here, and I will show you this in just a second. But basically what this will do is that this back end will attach to the back of the Stealthburner. One 8mm bolt goes in this way, attaches to the Stealthburner. Another one from the Stealthburner to this little cable chain holder will sit right here. And the actual drag chain is going to mount on these two holes. There's 3 holes on the original drag chain, but we don't need the third one because we have a little path right here for our CAN cable to sit. And so I had to model that out, and then the whole idea being that we want this drag chain to kind of sit perfectly on it like this. And if you were wondering why we couldn't flip this thing around to you know, sit flush up against this instead of having this extruded section, what happens is in the actual drag chain, I think there's some like limits on the edges here where you can't, it doesn't have as much hinging ability. So it really prefers to be in one way or one location. I even swapped it with the other side to see if it would be a little bit easier. And this back side is definitely meant to be static. It's a lot stiffer. It doesn't really hinge as well. And so this is the one side and the way that it is. And yeah, I actually have this part printed and implemented now, and I will show you this on the actual item. So here is the actual 3D printed part, and it came out really well. And I just used 3 heat inserts, just as you see.
And yeah, it printed out really well. It looks pretty nice and nifty, and it follows the same curvature of the actual Stealthburner. Let's get this installed and show you the drag chain movement. And here is that CAN cable with the drag chain fully installed right over here. You can see that it all fits really well, fits really good, and we will show you its mobility in just a second. But yeah, it fits really well, it looks really good, it's like perfectly in line with the rest of the Stealthburner. So very happy about this, and let me show you its full range of motion now. And here is the entire thing with the drag chain. If you can imagine that this is going to close, and you can see that it fully bends and is able to go to the back without opening and closing this panel, which is really, really good. This was really hard to do with the old setup. In the original drag chain mod, what would happen is this drag chain would kind of bunch up, kind of like this, and it didn't have any hinges here to kind of, allow it to close properly. And what I needed to do is that, one, I needed some sort of custom mount that was in line and level to what this mount was here. And the last two links of the drag chain I flipped. So these, you could see, just seeing that the way that they are, these have the lettering here 10 by 20, and on the back side here these ones have 10 by 20. So I flipped these two around, and I took the reciprocating piece here and I flipped it around, and I got it to work so that now it doesn't bunch up in the corner. Oh, and I'm gonna see if you guys can hear it clicking its X end stop. I hope you guys can hear that. I have actually created the new Y end stop, which is right here. I just haven't installed the actual end stop, which is actually it's just right here. It's held in with those self-tapping M3 threads. Why is that not in focus? I'm so sorry. There we go. Those self-tapping M3 threads. So just got to install that right back there, and then I can adjust its position and where it actually meets. We have the new, oopsies, we have the new X end stop like adjuster plate right here. So everything is going well with that. And another thing to mention about the drag chain, I'm not sure if this is exactly how it was made or if it was pre-installed this way. Yeah, but I noticed that it works very well for this. It kind of now makes this nice S that allows it to fully seat in the back. And yeah, I'm very, very happy about this. Also, the dampeners for our motors are coming in, and I will show you guys that in the next video. But I think that's all for this. I just wanted to show this thing now has full range of motion from the front all the way as far back as it possibly can go. So I'm very, very happy about that. And of course, super smooth motion because cleaned rails. So next up, we got to go ahead and re-grease the rails after cleaning them one more time. I got to think about how I'm going to place this motor mount. I'm thinking about possibly moving it over here and doing some other things, but that has been just this section with all the Toolhead items, and I hope you guys enjoyed. I hope it's been good, and leave your comments and thoughts in the description below. All right, bye.